What's up guys, this is Anupam from How to Make Tech. In this week I'm going to show you how to make a solar tracker. So let's get started. This is a little bit complex project, so I'm going to show you step-by-step guidance to make this project. So to make this, you're gonna need a 4-axis servos, and the servos have to be connected to a gimbal or something it can move 4-axis free. We are using servos because it's very good for positioning and the Arduino can easily control it. I mount my servos like this so it can move free ways. The servo has 3 wires: power, ground and signal. In this servo, power wire is red, ground wire is brown and the signal wire is yellow or orange. And my other servo, the signal wire is white and the ground wire is black. You can find this easily because the power wire is in the middle and the ground wire is in the left side of the servo and the signal wire is right. Okay, to track the sunlight you're gonna need 4 LDRs, also known as light dependent resistors. You have to mount it in a DIY board and you have to separate them from each other. You have to prevent any shorts or power leaks to this because this item controls the positioning of the servo. You have to connect one pin of each LDR and connect into 4 wires and separate them with the other 4 wires because 4 wires are going to power and the other 4 are going to signal. To make this project, you're gonna need an Arduino and a small project board and 4 220 ohm resistors, 2 10K variable resistors and some hookup wires. Okay, first you have to connect the ground row of the project board to one of the ground pins on the Arduino and connect the 5-volt pin to power on the project board. Okay, now take the 2 10K variable resistors and place them on the board. Now connect one of the 10K variable resistors middle pin to analog 5 and the other pin to analog 4. Both of the middle pins on the variable resistors are connected to analog 4 and 5. Now connect the left side of the variable resistor to power. Do the same to the other one also. And connect the right side of the variable resistor to ground. Now connect analog 0 to 3 on the project board. We will use them to connect that signal side of the LDRs. Now connect the four 220 ohm resistors to the one side of the analog inputs and the other side to ground. Now connect the ground to 220 ohm resistors. Now connect pin 2 and pin 3 on the Arduino to the project board. We will use them later to control the servos as signal output. Now connect the power pins of the servos to the power row on the project board and connect the ground pin of the servos to the ground pin on the project board. Now connect the signal pin of the vertical servo to pin 3 and the signal pin on the horizontal servo to pin 2. Now connect one side of the all 4 LDRs to power, that means 5 volts. Now connect the signal pins of the LDR according to this order. Analog pin 0, LDR top left. Analog pin 1, LDR top right. Analog pin 2, LDR down left. Analog pin 3, LDR down right. Okay, now connect the 4 LDR stand to the servos. And that is the last step. Now let's see how it works. Okay, I put a bright LED on top of my camera so you can see how it moves. You can control the servo speed by one of the variable resistor, and you can control the LDR signal strength by the other resistor. Okay, let's see the results of our project. You can use some solar panels on the side of the servos, and you have a full-time solar charger. And that is the end of my this week project. I will leave the source code to this project in the description, and I will see you in again next week. So if you have some questions, you can leave them in the comments below. If you like this project, put a like and subscribe for more videos. And I will see you again in the next week. This is Anup signing out from How to Make Tech.